even though one of our featured guests is not here yet, he'll be here shortly, we hope, because I saw him this morning when we spoke with an assistant to Congressman Devil. Dr. Giuliano Preparata will also share the program with me. My name is Dr. Eugene Mallove, and I'm representing Cold Fusion Research Advocates, which is the group of scientists and citizens who have organized themselves to, among other things, ask the Congress of the United States, one or more of its committees, to hold hearings on the subject of cold fusion so that we can have a clearing of the air on this most dramatic and important subject. As I say, this is sponsored by the Cold Fusion Research Advocates, which in a practical matter means contributions from my own wallet and that of my colleague Jed Rothwell of Chamblee, Georgia, and many other fine people who have helped support us. In fact, recently we had an angel give us $10,000 to attempt a replication of the famous Takahashi experiment, which is being reported widely in Japan, but is not being reported in the United States yet. Here it is in Scientific American, the Japanese edition, fully reported. But the American edition of March 1992, corresponding, does not have the story. If anything else summarizes what's wrong with cold fusion in the United States, that one fact alone doesn't. This is approximately the 3rd anniversary of the announcement of cold fusion, which is another reason that we should be gathered here today. On March 23rd, 1989, as you all know, Hans and Fleischmann at the University of Utah made a dramatic announcement that they had achieved what they thought was a nuclear reaction process generating excess power in what looked like a simple electrochemical cell. In fact, they have not backed off from that claim. Many others have gone on to reproduce the same effect. There were some defects in their electron measurements, yet others have gotten neutrons since then, tritium, many other particles. The point is that the Hans-Fleischmann claims have been substantiated over and over and over again. More important, and I will outline this in great graphic detail for those of you who care to listen to the gory details, the case of the negative position, that is, people getting negative results, is extremely weak. In particular, the MIT results, and I should know because I've investigated them very thoroughly, are very weak. Caltech results do not hold up either. The Harwell results, which are also touted as being negative to cold fusion, have some serious problems. There are unpublished papers on that. Okay, what is this press conference going to be all about? Let me give you a few particulars here. The first thing is I'm going to give some overview remarks, as I've begun to do already, and then I'm going to introduce my colleague, Dr. Giuliano Preparata, who will tell you about this wonderful new book, which is a 500-page volume which summarizes the proceedings of the Como, Italy conference, the 2nd annual conference on cold fusion last summer, okay, which was barely mentioned at all in the United States press. Okay, the only major American publication to report the existence of that conference was the Wall Street Journal, and there was a struggle even to get that article in. New York Times did not publish it. Science magazine did not publish it. Maybe someone else published it. I'm sure fine Utah publications published that fact. Besides Dr. Preparata and his discussion of the proceedings, we're also going to talk about the future of cold fusion research, both the science of it and the politics of it. We're going to talk about the congressional initiative to have hearings on cold fusion. And I'm honored that we have, I don't want to draw too much attention to him, but Kurt Johnson of Congressman Dick Sweat's office is here to at least listen to what I have to say. He's been very considerate. And the committee, people on the committee of the House Science, Space, and Technology Committee at least are listening to our earnest plea These are our scientists' names, and then there are citizens too. I didn't have enough room for them, but we have such minor figures as Arthur C. Clarke, Julian Schwinger, another science fiction writer by the name of Jerry Pournelle, the head of the Indian Atomic Energy Commission, the head of the Chinese fusion program, on and on and on. Many, many fine supporters. And scientists who are not directly involved in fusion research, but who realize that there is significant evidence to support the phenomenon and that it must be investigated properly. There will be ample opportunity for questions, but before getting into questions and also having Giuliano make his little presentation about the Como proceedings, I want to make some remarks. These were generated in my overnight train trip here to Washington, but I think they'll be coherent. First of all, why should I be talking to you about cold fusion at all? Who am I? Where do I come from? I live in Bow, New Hampshire, a town of 5,000 people. I am an MIT graduate, however, aerospace engineering, bachelor's and master's degrees. Worked in engineering for 15 years. I have a doctorate in environmental engineering from Harvard University in air pollution control systems. But in the mid-'80s, I began to get very interested in science journalism, and I became, for better or worse, a science journalist as well as an engineer. I consider myself both, and wrote a number of books, one of which ended up being Fire from Ice, Searching for the Truth Behind the Cold Fusion Furor. Okay, I still teach at MIT a course in science journalism. And I've been doing that for the last few years. But I did resign my position at the MIT news office, where I was when the cold fusion story broke. I resigned in June of 1991, rather than be a part of the disgraceful atmosphere that is now present at MIT, which saddens me greatly. It is my alma mater, after all. And it saddens many others, by the way. Some who are professors, who are interested in cold fusion, who don't want to speak up even. People in the cold fusion community don't even know some of their names. That's how shocking it is. But there were much worse things that led to my departure from MIT, which we can go into later if you want, such as gross scientific misconduct, fraud, quite frankly, which is passed off to the world as a scientific experiment that was supposed to tell people whether there was excess power or not, and completely obfuscates that issue. And yet that very data is now being used by patent officials to deny patent requests, if you can believe that. So I resigned. But I did become an expert, at least on the intrigues and the politics and the science, I believe, of cold fusion. And my assessment in this book, which ends the story with May 1991, I'm hoping to write a follow-on version of this. I'm in the process of doing it, in fact, getting the research done. At May 1991, the case was absolutely clear to me that excess heat, far beyond chemistry, had been demonstrated in many experiments. Since that time, it's gotten even more clear as more and more experiments are reported. The Como Conference had at least 2 excellent experiments generating megajoules per mole, which is far beyond chemistry. And now we have the experiment of Takahashi in Japan. Here's a color photo of he and his researchers in Japan working on this experiment, which ran for at least 2 months. Could hardly turn it off, and it generated so much power that even allowing all kinds of errors, even granting possible errors, even errors which he knows have not crept in, is still tens to hundreds of megajoules per mole of palladium. And for those who aren't as scientifically versed, what that means is the binding energies that connect ordinary metal atoms together give a certain value. I mean, if you want to vaporize palladium, let's say, it takes a certain amount of energy to break each bond. It turns out that the energies being released in these types of experiments are thousands of times more than those energies those bonding energies. It can't be ordinary chemistry. It's got to be something else. And since there's nuclear evidence, tritium, neutrons, other things, it's, as far as I'm concerned, in May of '91, I was definitely of that opinion, and I'm even more strongly of that opinion now. It's definitely a new nuclear process of still unknown and agreed upon, certainly, mechanism. Okay, what have I been doing since then? Well, I've been involved in this effort to gather petition names so that we can overturn the outrageous attacks against cold fusion, which all emerge from this worthless document, which was signed by a bunch of negativists for the Department of Energy. The co-chairman of this ERAB panel in November of 1989, who came up with this, Dr. John Huizenga, Professor John Huizenga of the University of Rochester, now has a book out. It will be out soon, and we'll all have great laughs reading it, because its title is Cold Fusion, Scientific Fiasco of the Century. I suggest to you that Dr. Huizenga's book will be called The Publishing Fiasco of the Century, because right at about the time that his book is being published, and soon thereafter, the evidence and products and mechanism for cold fusion will be so overwhelming that all we will have is the whining of people like Huizenga as they go dashing off to their corner to recant in private, or die with it, because as you know, the history of science shows, people sometimes never admit that they were wrong. So I've been trying to help the cause by getting this DOE report invalidated. What this report has done is to literally shut off money for funding cold fusion in the United States. Indeed, it's being done bootleg fashion in federal laboratories. People have to sneak around, and people are courageous and do it. There are some labs, Navy labs and so forth, where it is being done a bit more above board. But this is not right to have the Central Agency for Energy in the United States to be mocking this, literally mocking it and attacking it. We have disgraceful correspondence from Dr. Walter Polanski. Is he here, by the way? I've never met the man, I've had correspondence, but it's basically, it's always like, read our report, and we say we'll provide money, just give us the proposals. It would never be fair. Here's Dr. Giuliano Preparata emerging. So, it's okay, I've had a lot to say.
Washington traffic.
I didn't have to be that embarrassed about taking extra time. What I will do is I will say a few more remarks, which will go on and on too. I'll let Giuliano rest up a little bit from his dash here. We do have to acknowledge that cold fusion is indeed under attack, okay? Now those of us who have been under attack and been made fun of for pursuing this science, and by the way, I'm doing my own experiments now in my basement, okay? To replicate, I and others who are helping me, to replicate this experiment in Japan. Isn't that funny? That we have to get $10,000 worth of money to do an experiment in the basement in Bow, New Hampshire, indeed supported by many fine scientists from the MIT community and elsewhere, around the United States, by the way, giving me advice as to how to do this. Okay, I have my own ideas, and I'm drilling things and doing and working, because I've worked in labs myself. But the idea that DOE isn't instantly there, based on reports like this, to find out what's going on, wait till Congress really gets to the bottom of it. I'm waiting for that day. With great relish. But you're not going to hear anything from them for a while. They're hiding there. They've got their $500 million obsolete hot fusion program to protect. So we do have to acknowledge that it's under attack. Nature magazine basically has not devoted the coverage that it should to it, and in fact has attacked it. It has not put positive articles on cold fusion in. It hasn't reported the Como conference. I don't think that the magazine Science has been a heck of a lot better. In fact, they recently had yet another article by that infamous, unbiased journalist Gary Taubes reporting on Dr. Fleischmann's visit in California. Another disgrace. At least they publish correspondence, I notice, on cold fusion. whereas positive correspondence on cold fusion. Nature will not even put in a letter that is a technical letter that suggests there are major flaws in the Caltech experiment. 3 independent electrochemists have now found this major flaw. A high school student can be shown what the flaw is. They will not publish it. Arthur C. Clarke wrote to John Maddox, and Maddox says, we don't have the time for a review. It would take a lot of energy and so forth. Well, John, just publish the letters. We'll be satisfied with that. And while you're at it, you might review Fire from Ice, because after all, you did review the close MIT-generated book, Too Hot to Handle. All right. What are some of the remarks? Just to give you a flavor for this, because some of you really have not seen this firsthand, so you probably don't know the depth. You're hearing the depth of passion against it. But what prompts this? Why am I getting heated about this? Because a professor at MIT who helped launch the attack against Pons and Fleischmann, by the name of Professor Ronald Ballinger, said this, and he wrote this. This is published in the Gordon Institute proceedings. That's not the Gordon Institute of the summer seminars, don't get it confused. It's an engineering place north of Boston. He said, it would not matter to me if 1,000 other investigations were to subsequently perform experiments that see excess heat. These results may all be correct, but it would be an insult to these investigators to connect them with Pons and Fleischmann. And from Watkins himself, James Watkins, U.S. Secretary of Energy, in January of 1990. I think it is very premature at this time to say that we are losing a race in cold fusion when we have very clearly validated that we are not sure that it is fusion. That's the United States Secretary of Energy. And I met him at MIT recently, by the way, and I have a transcription of that encounter. He's relying on his hot fusion colleagues. Happer, one of them, is a Princeton guy who has got his name on this infamous report. And this is the guy that's advising him about Japanese experiments. In fact, he went on and on in talking to me about how Happer had gone to Japan and found them so flawed and so backward in their basic research. Well, they're not backward in one way. They're doing cold fusion research. Cold fusion is discussed in their major newspapers, and it's in their edition of Scientific American. So, Admiral Watkins, wake up. And MIT physics professor emeritus Martin Deutsch in May of '89 said of cold fusion, in one word, it's garbage. And then, of course, the great Robert Park, who has not found a week where he couldn't find a bad word for cold fusion. He says, most screwy ideas turn out to be screwy. Cold fusion was preposterous to begin with. And he called the first annual meeting of cold fusion in Salt Lake City, where he wasn't even present. He called it on national television a seance of true believers. And I could go on, but John Maddox, who's the editor of Nature, who I think may have to resign eventually over this, or at least change his magazine's name or something, he basically said this on the NOVA program, which we helped get canceled. I convinced the editors that it was such a travesty that they shouldn't be broadcasted. This is what he said. This is the final word of Nature on cold fusion. Even as all these experimental results come in, even a volume published by the American Institute of Physics, 1,000 pages, okay? But this is what Maddox, the great scientist Maddox, says. I think it will turn out after 2 or 3 years more investigation that this is just spurious and unconnected with anything you could call nuclear fusion, thermonuclear fusion. I think that broadly speaking, it's dead and will remain dead for a long, long time. I think he's really afraid that it will rise and come out of the grave and bite him, and in fact, it will. There are good magazines, however. The journal Fusion Technology, which is regularly publishing cold fusion research. It was formerly 100% hot fusion. Now it's about 30 to 50%. It varies. Sometimes it was 100% cold fusion articles. Published by the American Nuclear Society under the courageous leadership of George Miley. Okay? The Journal of Electroanalytical Chemistry, where Pons and Fleischmann originally published, also continues to publish both positive and negative articles. And they should both be published. We should know what does work and what doesn't work. But the answer to cold fusion is not to point to this supposed mountain of cold fusion negative experiments and say, see, I told you it doesn't work because we all know nuclear reactions can't occur at room temperature. No, the answer is look at what does apparently work and try to make it work even better. And that's what's happening in cold fusion. All the negativists, pretty much, have stopped their experiment in 1989 or 1990. They're gone. They're not even looking at the data anymore. Another journal, Japanese Journal of Applied Physics, is publishing Fusion Facts newsletter out of Salt Lake City. And last but absolutely not least, 21st Century Science and Technology, which is published by a political group with which I am definitely not affiliated, but which is to be absolutely commended for publishing a fine, continuing series of information on cold fusion. I only wish that Nature and Science had as much coverage of cold fusion as 21st Century Science and Technology does. And there are other magazines too, and I hope I haven't slighted anyone. The Japanese publications in Japan are great. There are about 6 cold fusion books in Japan now, by the way. Mostly positive. Okay, I'm going to say one thing and then Giuliano take over. Just in essence, what is the evidence? The evidence is this massive heat, as I told you. You can't do this with chemistry. There's no explanation for it. And at the same time, in similar systems, or simultaneously, a weak trace of things like tritium production, neutrons low level, or burst phenomena, and then charged particles from thin films. These things have no conventional explanation, but it doesn't mean you have to repeal the laws of physics. You just have to look at quantum mechanics, a little differently perhaps, put things together with building blocks like lots of fine theorists, like Dr. Preparata here and Dr. Chubb in the audience have done, and try to explain it. And believe me, there are excellent explanations. So without further ado, I'm going to turn over to Dr. Preparata. And then after he makes his fiery remarks, or perhaps less fiery remarks,
Icy
remarks, I will come back to make further fiery
This time
remarks.
it will be very icy. Okay. So, maybe I can stay here, or you want me to go?
Who want to podium?
Well, I'm sorry I came late, but actually I was doing what I believe was my duty in trying to talk to the people who have the responsibility to sort of make society work. Capital here, you know, to just let them know that there are things and that are happening, and presumably there are usual institutional channels of advice haven't somewhat been clogged recently, and in such a way that important information didn't pass. I think this is what Dr. Mallove has been telling you since the beginning of his presentation. So I spent essentially 2 days of my time on this visit in the United States really trying doing this kind of service to a friendly nation like the U.S. is, and also very familiar to me as I have spent a large part of my early career in this country, and I have learned to appreciate its openness and its high commitment to fundamental values. However, these fundamental values, I must say, have seen a little bit less clearly in the eyes and in the mind of a certain number of colleagues who have now the responsibility to advise the government and to sort of hand out research funds to the academic and scientific community of this country. And this is the thing that Mallove was talking about, and I really have he knows the situation here much better. I know for myself that we are under very difficult conditions as well in Italy, and which is, however, the only country in Europe where there is some kind of effort along the lines of cold nuclear fusion. But, and I think the reason is highly depend on the fact that the American scientific community really has an enormous amount of influence and power as well through its great institution of the journals of the American Institute of Physics and the various journals, conferences, and the very tight-knit community of physicists and chemists. So therefore, their advice certainly comes to our country, our countries, and has a tremendous amount of weight. So, the reason of my being here, therefore, is to present to you facts from a recent conference that we have held according to all the well-established procedure of pure scientific conferences. Unfortunately, the conference in Salt Lake City, which was meant to be a good scientific conference, somewhat deteriorated, I believe. At least this is my opinion, finding myself in the hallway, talking to journalists up to incredible hours in the morning, deteriorating in a kind of, circus of press and scientists, and also maybe it was a little bit too early, I must say also, to try and make a fixed point, try to reach a conclusion about this very disquieting and very strange, anomalous results that people were finding in the metal deuterium system, because this is essentially what we're talking about. In Como, only very few journalists were there, and the ones who were there, and I know a few of them who were there, were quiet. They let the scientists talk. They didn't interfere with their proceedings, with their way of approaching the field. There were 5 days of very intense discussion, confrontation, presentation, reviews. Everybody had a chance of intervening in the discussion, which was never really cut out. So at the end of this scientific, we came out with the conclusion that this results, this strange effect that were first reported, announced to the world by Fleischmann and Pons, were indeed real things, and they were very worthy of, they deserve to be looked into it, and the research effort ought to be escalated. And I think that this was the real, in my mind, fundamental point of this conference and of its conference proceeding, to which we have appended, given a title, which really reflects what went on in Como in the beginning of July 1991, and that is the science of forward fusion. After so many gossips, so many confrontation on a ludicrous point, we finally came to a point where we could serenely, lucidly discuss our differences, our points, scientifically, and just say exactly what the results were, and say what the ideas in order to explain them were, and in the most straightforward and I think time-honored tradition of scientific interchange and intercourse. And so, I mean, just having said that, I would try and briefly describe the contents of this book, what are the highlights of this book, just to show you. This book, by the way, has been published by the Italian Physical Society, so it's a book of their collection of conference proceedings. It has been refereed by a few physicists, so it has really come out, the contribution have come out following, standard procedures. So nobody really can say that this is a seance of true believers or whatever. It's just people who are willing to stick their neck out on what they say. They believe it's true. That doesn't mean that they are right. I think this hysteria with making mistakes is something which is most obnoxious, and in fact contrary to the interest of science. Science thrives on mistakes, because Scientific progress really consists of making mistakes and correcting them. That's exactly what it is. Not recent history, but the history of science, to see how the people who were so attached into thinking about the Ptolemaic system accepted the new Copernicans, and in fact how they sent Giordano Bruno to the stake and Galileo almost to the stake, but then took the confinement of the last 10 years, 15 years of his life, of his fantastic life, with a very sad end. Those were the people who were righteous and convinced that they ought to stop the nonsense of the Copernican heliocentric view of the world. And in a way, in a way, some of the people are behaving, in these days, they're really going through a well-known pattern. And I think, presumably, just following what a philosopher said, people who don't know the history are condemned to repeat it. Presumably, that's the problem. So the content of this book has a certain number of highlights. There are certainly the experiment by Melvin Miles and collaborators at China Lake, at the Naval Lab of China Lake, California, who, with Ben Bush, Lagosky, who show that the cells that give out excess heat with a rate which is comparable with what Fleischmann, with the rate that was given in the early announcement of Fleischmann and Pons, when analyzed, when one looked at the gases evolved out of the electrolytic cell that gave excess heat, one would find a quantity of helium-4 which was commensurable with the quantity of excess heat, in the sense that if we believe that each diffusion gives off a about 24 MeV of heat and helium-4, then you find out you can count the number of helium-4 which you expect for a certain for the production of a certain amount of heat, and you find the essential thing. And he has about 10 cells that have done that, and he finds helium in all of this, and then he has blanks, meaning cells which work with light water or what have you, or with the palladium over platinum electrodes, the cathode instead of palladium, or the ones who simply do not give excess heat, because we know that the ones that should give excess heat. Now, and this is another point, then he doesn't find anything. So the probability that what Miles finds is an artifact is very low. It's the order 10 to the minus 4 or something like that, being the artifact. And that, I think, is a very, this is a very significant contribution. This has been published in a well-respected scientific journal, like the Journal of Electroanalytical Chemistry, and the scientific community, the ones who are very much against all this phenomena, have taken no notice of it, nor have they deemed it important and reasonable to change up their mind, nor have they deemed important and interesting to challenge the result. The whole thing has been just left in total, has been ignored, essentially. So this is one thing. The other thing is the results of Mike McCubrey, who Mike McCubrey, I will recall to you, is the leader of the lab where recently at the beginning of the year, a very tragic accident occurred, taking the life of a young researcher, Andy Riley. It is interesting, parenthetically, that after more than 3 months of that, essentially a tragedy, a scientific tragedy, there's still no report made as to what the causes of that explosion were. And I myself, having talked to some of the people who were involved in it, have made a good conviction that that explosion occurred the occurrence was due to runaway of the nuclear type that Fleischmann and Pons had already warned against in their original paper in the Journal of Electroanalytical Chemistry. So Mike McCubry at Como presented the results of his group. By the way, Mike McCubry is the one who's going to receive, according to a recent release that appeared in press release that appeared in the Wall Street Journal, is the recipient of a grant of $12 million in 3 years for research on cold fusion, financed by EPRI. He presented a very sophisticated calorimetric analysis of a certain experiment of the Fleischmann-Pons type and concluded that he had foolproof evidence that there were power releases in the order of 10 watts per cubic centimeter of palladium of excess heat, and he also made a very systematic analysis as to what the condition of loading for the experiment we were successful were. And he concluded that the condition of loading were such that the ratio D over PD should be close to 1 in order of the number of the deuterons of a palladium atom should be close to 1 in order for the nuclear events, the nuclear fusion events to take place. This is the most direct experimental analysis and findings, because it would give a completely rational explanation of all reported negative results. Insofar that the people who find negative results are not able to show evidence that they were able to appropriately load the electrodes of their electrolytical system, no reason should be found whatsoever that they should get positive results. And a very important conclusion in a panel of the conference on Como came out, really to that effect, that we are not going to accept negative evidence if what appears to be a necessary, even though not yet sufficient condition for getting a result are not met. I will also mention the results by Stan Pons, who shows the result of a series of experiments that he conducted both in Utah and in his new lab where he's working now in Nice, where with palladium alloys, with electrodes of palladium alloys with silver, he can really get to very high power densities on the order of a kilowatts per centimeter cube. These experiments have been repeated also in Nice, and his calorimetry and his analysis for excess heat has been independently evaluated by Wilfred Hansen, who had the task from the Utah Committee on Energy to evaluate the result, the work of Stan Pons and Martin Fleischmann, and we published as an appendix to this book, the report, very detailed report is given, of which of course he had given excerpts at the conference he has given to the Utah Committee on Research. I don't know what Utah will make out of this, but I mean, this will, I hope, this will finish, this will end the, forever, from the scientific standpoint, the controversy whether Fleischmann and Pons were good enough to measure that amount of heat. And in fact, the conclusion with a completely different system of analysis to Wilfred Hansen are totally in agreement with the original conclusion of Fleischmann and Pons, and the conclusion for which they were essentially driven out of this chemistry. And this ought to be underlined very strongly, because I regard that as well, I think, can I use a strong word? As a shame for this country and for the scientific establishment. Then there is an interesting review of the conference by a person who was skeptical. I mean, Heinz Gerischer is a very well-respected, very famous, I think he's the dean of the German electrochemist, who was invited just because we're not a sense of true believer. We wanted to have from many places eventually negative feedback, and he came very skeptic, and in his final talk, he became actually quite optimistic, quite open. And I understand later on he even went out of his way, sending a memo to his colleagues in Germany and urging them to take up very seriously this kind of work. Well, there are many other things. I hope you will see them of yourself. I don't want to take more of your time. I only wanted to convey you the feeling, and that in fact what was found at Como finds that the last events, both tragic and hopeful, that happened are a most important confirmation. And finally, I would like to tell you, just to report to you, a statement that Stan Pons gave in Italy at the workshop that we have organized in Torino for the people of for the small community of people who are now pursuing in Italy called fusion. And Stan Pons, to a journalist of the Italian RAI, yes, made this statement that he thought that a demonstration device could be presented to the public before the end of this year. And that is a very hopeful thing. Thank you very much. Now, I think should we go through some...
We'll have questions. I think that would be an excellent thing. We definitely want to do that, but I just wanted to mention one concluding remark or two, if I may. Basically, I think to summarize the totality of the remarks that I made earlier and now backed up by this excellent review of the highlights of the Como results, what's happening now basically with the negative position against cold fusion? Three words basically: arrogance and vested interests. The arrogance, which has been there from the beginning, but which is even worse now, leads them not even to look at the data any longer. They don't look at the data. In fact, the reason why my technology review article, 9,000 words, was first approved by the editor and then mysteriously withdrawn was from a physicist at MIT, Dr. Feshbach, whom I asked about his views on cold fusion, just to find out why he had blackballed this article, which was a middle-of-the-road sort of article on cold fusion. And he said, I've had 50 years of experience in nuclear physics. I know what's possible and I know what's impossible. And then when I offered to show him the review, I think it's in this issue of August '91, Edmund Storm's review, or pending, it would have been pending that issue. I said, you want to look at the review by Edmund Storms? And he said, no, I don't want to look at any more evidence. It's all junk. And he hung up. That's it. Now, the other vested interests that we're getting, not only the vested interests now of hot fusion, by the way, but now we have the vested interests of those who put their foot so deeply down their throats that they can't get it out. They're going to have to admit they're wrong eventually, and they know it. That's the whole thing about the negative position. And another thing I do want to bring up, because it's fun and it's also very historically enlightening. Giuliano brought up the very key point of Galileo, which I agree with entirely. Originally, even when I was being tortured at MIT in last June, I felt that bringing up the Galileo parallel might be a little too strong. But the more I look at it, the more clear it becomes that it really isn't much different. It's just happening in the modern era. But there's another interesting parallel, which would be particularly good for journalists to hear. Because I think there's a feeling among journalists in particular that how could this be that a revolutionary technology is is emerging here? How could this possibly be? Is there any precedent for this? I mean, there's sort of a lack of belief about this. Well, guess what? There is, and I wish I had realized it before I finished my first book. I'll put it in the second book for you. Read Fred Kelly's authorized biography of the Wright brothers. And if you want to skip the beginning, begin at about page 60, and it will be like a deja vu experience. And I just wanted to review just a couple of little passages here. The Wright brothers, as you know, flew in December of 1903, but it was 1908 before the United States government acknowledged that they had a flying machine. They actually wrote letters to the Wright brothers after much correspondence saying, prove to us on paper that you have a flying machine. This was after they were flying all over the place, and the two of them were virtually exiled to France. Another parallel. Here, during this time now, we're talking about 1905 now. They still haven't been accepted by the world, even though they're flying all over Ohio, so to speak. During this time, the newspapers had continued to let the Wrights alone. Indeed, the failure of the newspapers in Dayton and elsewhere to say much about the history-making experiments at Huffman Field was often used as an argument to prove that there couldn't be any truth in the rumors that men had actually contrived a successful flying machine. You couldn't have kept a thing like that secret. Some reporters surely would have heard about it, was the remark. Dan Kumler, who was city editor of James Cox's Daily News in Dayton during those early years of flying, recalled in 1940, not long before his death, that many people who had been on interurban cars passing the field and seen the Wrights in the air used to come to the Daily News office to inquire why there was nothing in the paper about the flights. Such callers, said Kumler, got to be a nuisance. And why wasn't there anything in the paper, he was asked, Kumler, before he died. We just didn't believe it, he said. Of course, you remember that the Wrights at the time were terribly secretive. We've heard that too, haven't we, about cold fusion? You mean they were secretive about the fact that they were flying over an open field? I guess, said Kumler, grinning after a moment's reflection, the truth is that we were just plain dumb. That's the whole story, friends. And now if you have questions, we will answer them for you. Surely there must be questions. Yes?
What are you finding in your basement?
What am I finding? Rats, dirt. We started a very crash program to attempt, we have a microphone person here. I used to be a VOA person, so I know the need for good sound. To attempt to replicate this amazing Takahashi experiment that we've heard about. We don't have the thing running yet. We're preparing to do it almost exactly as he did it. He has a cell which contains about 500 milliliters to 600 milliliters of heavy water with 3/10 molar lithium deuteroxide, which is about 3 times the concentration that Pons and Fleischmann used. And it's a plate electrode, 1 millimeter thick by 2.5 centimeters square. And in addition, he claims that he got turn-on of excess heat after about 5 or 6 days by using a sawtooth current profile input into the cell, doing something, who knows what, to the surface of the palladium. So we're going to attempt that. Whereas we've assembled most of the equipment, and we're going to try ultimately to do a control experiment. But the first thing we want to do is replicate this exactly as it is. I mean, we're trying to ensure, for instance, that he says he built this out of acrylite, we're building it out of acrylite, not plexiglass, which is really the same thing. If he says use polyethylene blocks, we're using polyethylene blocks. There will be a few departures. We, for example, will put are putting heavy insulation around the cell, except in the front, so you want to look into it. But it's going to be more isothermal. I mean, not isothermal. It's going to be more contained with the heat. And the heat that's being taken out is coming out of a heat transfer loop. We're going to calibrate it in 2 ways. The way Takahashi did, by measuring the difference between the center of the cell and the chilling water that circulates in. Also, we're going to measure the difference between the inlet and the outlet temperatures. And we're doing this with a couple of computer systems. We're not going to measure nuclear particles. Here Takahashi is with his graduate students using neutron moderator blocks. We just want to see whether we can reproduce it. We may get a negative result. That will make me disbelieve in cold fusion. Yeah?
But then you wait with the press conference here you are able to present some kinds of results.
Oh, I'm just telling you that I'm doing an experiment.
Timing.
Is there something, bad timing?
So yes,
Why?
because normally you have to,
Well,
you know.
no, normally
you're
people
trying
say...
to present
No,
some
no,
kind
no.
of...
Sir, you have it wrong. Sir, people say that they're doing experiments. That's all I'm saying. I just told you that I may get a wrong result, I may get a negative
So
result.
how
and I
about
announce that to the world.
perusing through this book?
Hold on.
Because here this is just the results that have been presented by close to 100 chemists and physicists.
Oh, this is an interesting...
to this effect.
This is interesting. First of all, I very much appreciate knowing why you feel that my discussing an experiment in progress, which is attempting to duplicate something that is published in Scientific American of Japan, why stating that is bad. Is there something bad about that?
No, but if you are able to come out with the same results, you know.
Yeah, I'm not claiming that I have them. In fact, I'm telling you most definitely and clearly, we might not get them because his experiment might not be reproducible, or maybe he has a wrong experiment. From what I've heard of it so far, he's being totally open. Every question we have asked him, such as, exactly how did you weld this to this piece? Exactly what is the thickness of your glass and so forth? He answers to a T. Now, a great criticism of Pons and Fleischmann was made that they were secretive and so forth. I'm saying he's very open, and I'm going to be very open about saying that this experiment is in progress. And I'm going to say also that it does have a little bit of a political message. It does, and I won't deny that for a minute. The message is this: since the Department of Energy has literally decided not to fund this, and that's true, I'll give you the correspondence to show that, to fund any of this work, except as Admiral Watkins says, for monitoring purposes. Okay, we want to show that there are other people who think it's worthwhile. That's all. And I hope that message is absorbed. Yes?
If in your own experiments you are not able to get any positive results, how would you interpret that then?
I would interpret it one of several ways. I would, first of all, we hope that it will actually turn on. You know, I mean, that is, we will actually get to the point where we've gotten enough computer equipment together and all the requisite things so that we think, okay, now at least we think we are ready to press the button and collect data for weeks or months. I hope we get to that. I think we will get to that reasonably shortly. But if it fails, if let's say we do this sawtooth for a week or 2 months or a year, and we keep adding heavy water and it keeps electrolyzing and no excess heat appears, I will interpret it in one of several ways. I will interpret it as, well, in this particular experiment, which we thought was exactly like Takahashi's, we didn't get excess heat. And that could say one of two things. It could say that, and we would check that very carefully, that there was something that he may have done that was wrong, that there was a flaw in his experiment. We already found a thing that we didn't understand about his experiment, just based on the way he published it, and we corrected that misinterpretation in our own mind, so that's one accomplishment we've had already. But it may also be that we would come to the conclusion that he really did have, I think we probably would come to that conclusion, that he really did achieve excess power of this significance, but that for some reason the microstructural aspects of that particular piece of PD, even though it comes from the same company that supposedly manufactured his, wasn't right. Something was wrong. Something was ajar. Now, I think offhand, my hope, and it's just a hope, that he's turning this current on and off over a great range, going from 1/4 of an amp to 5 amps. Okay, that's a very sort of a jarring process. And to me, it's pretty impressive that over this 2 months, at least if you can believe his result, that it didn't stop. Okay, his report of excess heat seemed to be pretty consistent. I'm impressed with that, and it gives me a little hope that maybe our crude system will also be robust. robust like that, or it may not work. Just another dead end. Then we'll try again something else, assuming we have
If
fun.
it doesn't work, then you're saying either there's a problem in his experiment or a problem in your experiment.
Yeah, that would be the obvious logical thing. Either we have a problem, or he had a problem.
Of course he has a problem. I mean, because what the study actually saying, he's seeing something that has been seen by other people. Now, the real question is to find out what are the crucial parameters of the reproducibility of this. Now in Japan, they have tried to have new ways of preparation for this kind of electrodes. So, all right, I mean, still, I mean, is in the cooking kind, you know, it's a cuisine kind of experiment, because maybe you could work it, maybe you do that, and then you try. Maybe you think you have the same, maybe you think you have the same electrode, and you don't have the same electrode. So, I mean, I'm sorry, but the fact that now, you know, all this question, what do you do with that, what do you do with that? Why do we have to go away, you know, throw away, you know, all this has been done, has been checked by other people. It's clear that the phenomenon is a complicated phenomenon, and what is the effort that is going on now is really to try and assess what are the conditions to do that. But to really just ask this question of yes and no, I mean, to me, it's totally unscientific. Because in the way, what are we asking really people to do? It's clear that the phenomenon, the fact that you have fusion in a metal matrix different from fusion in a plasma, has to do with the environment in which the deuterium find themselves inside this object. Now, when you say, oh, this is a piece of palladium, this is a piece of palladium, we know very well that, you know, in order to really say these two things are equal, we have to check at least 10 to the 23 or more variables. 10 to the 23 is 1 with 23 0. Now, you understand? Clearly, if you are here asking macroscopic properties like, you know, the dilation constant, the heat capacity, and all these 10 to the 23 variables are going to average themselves and always give them more within the measurement the same answer. But here we are really tapping on something very subtle. Something which is so subtle that it was even thought about, you know, before it could be possible. So all this enormous amount of requirement on the reproducibility, it's just a kind of bad habit, you know, that people, intellectual habit that people have in my field, which is high energy physics. You have you know, usually, you know what the experiment of high energy physics is? Just you have two things that go one against each other, and they do things. They do things. You just control the energy, control the momentum. You do this, and then they will do, under the same condition, the same kind of thing. But here you have a system which consists of 10 to the 23 Avogadro number of objects. And they can have dislocation, I can have imperfect impurities, blah, blah, blah. So, I mean, I think to be so sternly demanding, this is the question of the double standard. If you ask the people doing in the labs of solid-state physics, I mean, the cuisine there, the repeatability of this thing is almost zero. In the end, they learn how to do it. But then, of course, this is done within a well-established, you know, Nobel Prize-led kind of labs, so everything is fine. So you come up, Fleischmann and Pons, you come up with a new concept, totally new concept, in a complicated thing. It's absolutely amazing the whole thing works. It's amazing that this thing, in fact, has continued to work. And now, you're asking just at the beginning of a field where a few courageous persons have been, you know, you really require guts to stand the ridicule, the contempt, and other things that we have experienced. All of a sudden, my class is very brilliant, you know. If you just look at my curriculum, you see that it's a brilliant career. All of a sudden, I find myself an idiot in this community. How can that possibly be? Okay? But this happens. Now, fortunately, they don't use stakes anymore. Because I could even run that risk. Okay? I want you people to understand that we are really in a very serious situation. Science has become totally Aristotelian just because big science cannot tolerate an abrupt change of the paradigm, because all the value system, all the money system is based upon it. And we have to face this. Now, the taxpayer, who has nothing to do with this minority of Brahmins who dominate everything, has to understand that science, in order to be useful, must be for the people, not for its own furthering. And this is told you. I mean, he's a scientist who has lived through it and who has dedicated all his life to it, and is sincerely concerned. But I couldn't believe, when I was a kid and coming up, in a very well screened environment, you are brilliant, so you're going to make a career. I could never believe that as soon as I gained conscience that something ought to be changed, I would be dropped so violently and without any, this way. I could never believe this to happen to me. This has happened to me, in a way. Fortunately, then I got to get tenure in the Italian system very early. In the Italian system, now I have the degree which is almost that of an ambassador because I am a civil servant. I have no boss, so I can go on. But they will kill my students. They will not give them position. That is what they are now doing now. So they cannot do anything to me, but certainly they are going to subtract from me the audience of the young people just by making, a career blackmail. And they're doing it.
I want to confirm that it not only happens in Italy.
Well,
I won't use the professor's name, but it's obvious. A professor well known for following cold fusion at MIT has had students who wanted to work on cold fusion told by certain members of the physics community there that their careers would be ruined if they go over and work on this. Okay? Ron Parker, the head of the MIT Plasma Fusion Center, who has got an experiment that charitably I will call grossly incompetent, onto which fraud was imposed. Okay? And if anyone wants to read the letter of Dr. Charles McCutcheon of the NIH, okay, who is not a believer in cold fusion at all, he sent a letter to President Best of MIT stating how outrageous that experiment was and how things have to be done and how it has to be, in effect, retracted or modified because it's grossly incompetent and fraudulent, likely. Okay? That man said in Science of Peter Hagelstein, he said, and this was in the spring of '89, he said, I think it was the spring of '89, or maybe it was December of '89, something like that. He said, in principle, he had no problem with Peter continuing work on cold fusion theory, but it calls into question his judgment. Okay. That anyone should be so insane as to work on this, when we all know that the MIT data, there it is, focus in on it, showed, the published data shows that there's no difference between heavy water and light water. But 3 days before, there definitely was a difference. Now, I don't say that proves cold fusion. In fact, it certainly doesn't prove cold fusion. But to put this forth to the world as a negative is disgusting and outrageous, and the way it's being continued is even worse. Here's the unbiased view. The person who doesn't care, he cares whether cold fusion is real or not. He wants to know, Dr. Charles McCutcheon. But he says, this is what he wants Best to do, which I don't think he will do. I think they're conducting a secret investigation of this, which they won't even admit. It's fascinating the way they haven't learned the lesson from the Baltimore affair. This is quoting McCutcheon. It was a public letter. He said I could release this to anyone. For its own good and to restore some civility to a contentious field, MIT should look into 1, how its scientists came to perform and publish such a poor experiment. That's an understatement. 2, why they either misdescribed their results, making them seem more meaningful than they were, or used a subtle correcting procedure without describing exactly what it was. 3, how it came about that data from calorimeters with a claimed sensitivity of 40 milliwatts converged between drafts after completion of the experiments to within perhaps 5 milliwatts of the result that hot fusion people would prefer to see. It might have been chance, but it might not have. And in fact, my friends, another scientist interested in cold fusion, whose name is Dr. Mitchell Schwartz, who has 4 degrees from MIT, has a paper which he will publish, and which I can show you the color graphs from. I'm not at liberty to show you the paper. He uses polite language, but I, in my letter to Vest, interpreting his paper, say that this is now clear evidence of scientific fraud. This paper, with its graphs, shows that there is no way that you can get. Here's the thing. Here's the light water, heavy water. Day 1, unpublished. Day 2, published. You can go from here to here with a simple known transformation. You can't go from there to there by any linear transformation. There are added data points, 20% more. These 2 points have been added. They were calibration ticks. Come on. We know what that message is. The message was, in 1989, get rid of this. And they have been assaulting and attacking Pons and Fleischmann on their alleged shift of data, which is rather ironic, because they look in the mirror and they should see what they did themselves.
They knew what they're talking about.
Right, they knew what they were talking about. Yes?
Who do you believe is behind the opposition to cold fusion?
I don't think there's a conspiracy. I think there are, I said, there are 2 things. Arrogance and vested interests, okay? The arrogance is from those, well, look, I listened to what Parker and Ballinger said on tape. You know what they said in their attempt to plant a story in the Boston Herald to attack Pons and Fleischmann, which they then, when they saw the exact details of their words on the front page, they almost got a reporter fired. Do you know that Nick Tate of the Boston Herald could have been fired? And he said to my class, I probably would have been fired if I had not had that tape. He said, and Ballinger said, of course we know where all the good scientists are. They're in Utah, right? Ha 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 ha. That's what they said on the tape.
Well,
They were arrogant, and they still are arrogant, like Hermann Feshbach, the expert on nuclear physics, who won't open an article and look at it because he thinks he doesn't need to see any more evidence. His own society published this.
This is very similar to that, to get back to the Galileo affair, to the very well-known episode where his colleagues at the Studio di Padova, the University of Padova, where Galileo was at that time, wouldn't put their eyes in the telescope to see that, in fact, there were sunspots. There were very well-known sunspots, okay? They wouldn't put their eyes in the telescope because it had been proven by finally by Aristotle, that there couldn't be any element of corruption in the world beyond the moon, in the superlunar moon. And this is, I mean, the attitude of our colleagues have been exactly the same. So that's why, I mean, it's for me, that I happen to know a little bit of this history, I've studied it, it is appalling to see how it's been really reproduced, relived, in a way.
No, I think
Larry
was first.
Dr.
Larry was
Preparata, I understood from speaking to you a little bit earlier that you came out of particle physics. You came out of really the standard school of this thing, and yet you're looking at cold fusion because you see something here that is that you're getting at something with respect to the whole standard model, the whole QED, QCD model. Can you explain that a little bit further, what you're seeing here?
Well, I mean, thank you for asking me. It's true that my interest in cold fusion really came from a previous experience, which goes back to my thesis, PhD thesis, back in '64, on the question of elementary particle, what was then called elementary particle physics, which later has become fundamental particle physics, if you want, and it has been synthesized in this great achievement of the human mind, which is called the Standard Model. Now the question is, we have seen so many of these results, you know, the electroweak interaction, the color interaction, the quarks. Everybody, you know, knows the quark, and most people know that the quark really pose a very great problem to the human mind. This is, you know, in this atomistic idea that you can chop off, you can, you know, break everything in smaller pieces. And this has been a tremendously successful line of research. We have come finally when we are hitting this particle, which are called the hadrons, of which the protons and the neutrons is one example, but there's so many, we are hit a point where somehow the constituents, the quarks, that are deemed to be, the constituent of this system, cannot be separated in any way from the container, the hadron. And this, of course, the idea of parts and whole at this point becomes very confused, because in other words, the whole doesn't seem to be able to exist without its parts, and its parts without the whole. So this process of analysis, which has been extremely successful in breaking up the matter in smaller and smaller constituents, then stopped there. For me, this was really the obsession of my life, to try and understand how this was possible. And out of the obsession of my life, I realized I developed an idea of what the ground state, what the vacuum would be, in a system where there has a very strong interaction among the field, the so-called gluons. Okay? So I think I believe I've given a solution of this problem back in '85, which has been totally neglected by the community because it was not conducive to another, to the ideology of modern physics, of modern high-energy physics, which has led to the SSC. I don't want, I don't want really to attack the SSC here, but I only want to say that this ideology has given a tremendous price onto going to the structure of matter at smaller and smaller space-time distances, rather than trying to understand how these little objects that are quarks really live together and make a whole, which has very peculiar properties. In any case, this is not important, very important to say, but what is important to say that this experience and this solution of the problem gave me a good idea that condensed matter could be, under certain conditions, very similar to the ground state, to the vacuum of QCD. Okay, I cannot explain you exactly why this is so, but this is a true statement. So therefore, I developed an analysis of this ground state in terms of macroscopic quantum field theory. It's exactly the notion which gave me the possibility of understanding quark confinement. This is called quark confinement, the fact that quark has confined with the atom. And I was able, to understand a certain number of things, from the free electron laser to water as a kind of a free electric dipole laser, something like this. So when the Fleischmann and Pons announcement came, after a little bit of skepticism, because I really didn't know really what was, but after I learned from the paper of Fleischmann and the reports from friends who were sitting at the conference of Fleischmann at CERN and so on, I learned what this was really about. I could immediately relate this to the work I had already done and found out it made sense. In fact, with my friends Tullio Bressani and Emilio Del Giudice, we published in the month of May 1989, less than a month and a half after Fleischmann and Pons' announcement, we published a paper in Nuovo Cimento, which is the Journal of Italian Physical Society, which had the title Words and Understanding of Cold Nuclear Physics and so on and so forth, which contains essentially the idea, differently from Peter Hagelstein, I didn't have any reason to change my idea up to this point. Okay? And, this is still rudimentary, but I think those ideas, that paper contained the basic ideas that would make a piece of magic would make it back to the realm of scientific rationality. And this is so, and to see that people were legislating, my colleagues were legislating against, like Hermann Feschbach and the other people, against this just on the basis of an incomplete and finally incorrect use of the laws of nature, really made me mad, because I showed that these people, of course, Hermann Feschbach is old, he's not able to learn, or less able to learn things. No. This is something that I'm going to subject to. This is something very grave and sad. That you see that, the more you're advanced, the more things you know, the least easy for you is to incorporate new ideas. And that's a tragedy of a scientist. That's why people should leave, should not, I mean, people, this kind of society tends to believe more the senior people. I don't say that they shouldn't be believed. I'm only saying that there's this tragedy in the approach of the human mind to the new, to the emerging, okay? And that's what it is, that, you know, you essentially, you cannot be able to tune in, you are not able anymore to tune in to new things. And unfortunately, society takes people with Nobel Prize, for example, who usually is rather old, who's been a scientist much more lucky than anybody else, who have had one good idea in his life, and they think they're going to have two. It's impossible. And it's impossible. So, I mean, this society gives a tremendous amount of weight to the advice and to the opinion of Nobel Prizes. And I think the chance that the Nobel Prize, who was right once, is able to be right twice, is just zero. They should rather give other people the chance. And then, you know, and then, of course, my plea here is for a total openness, no authoritarianism in science. Everybody has who thinks that an idea has to come to the fore. Of course, he has to be shot down if he's wrong. I mean, in fact, this creates a tremendous amount of moral tension in the people who are scientists, in order to be able to judge by themselves, for themselves, whether something is right or wrong, whether something is in agreement with the facts or not. Of course, it's much easier to say, what does the DOE say? What does MIT? MIT is the greatest school. What does MIT say? Wrong. Okay, fine, let's go. Very easy. But very much against the science itself. So I think, you know, I don't know whether I have given an answer to your question, but true, my interest in cold fusion was really a corollary of work that was essentially occupied the better part of my scientific life. And I think I'm glad that these two things came together.
I just thought you might tell people about the coverage of Takahashi's work in Italy.
Okay.
Reflect on the press.
Yes, Takahashi didn't come to Italy, but he comes to Italy, a friend of, and a closely related scientist, who's Hideo Ikegami. Hideo Ikegami, who's the boss of both the hot and cold fusion program at Nagoya. And I don't know exactly what it is, but I think he's been involved in both aspects of the fusion program. And he was invited to give a talk in Frascati, who's a lab of the Italian National Institute of Nuclear Physics, INFN. And he gave a very effective presentation of the work of Takahashi that really stirred an enormous amount of interest in the Italian press. There were important newspapers like La Repubblica, Il Corriere della Sera, and others. La Stampa no. It's interesting, La Stampa is owned by Agnelli. Agnelli is the boss of Fiat, and he has other agendas. I know that he is involved in hot fusion. So La Stampa consistently plays this thing down. But okay, these were the two major newspapers, and I think they gave a picture which interested very much the community, the Italian community, the Italian people, and we hope that we are now living on a tail of this enthusiasm, and we hope as soon as I get back that we'll be able to do something with Congress. Well, now there are elections, but okay, after the elections, of course, the 5th of April, the election. So with Congress, we'll be able to do things like this. But I think also, I mean, a lot has to do with the real threat that people, you know, take. Not threat, I mean, the psychological threat to be, you know, in the competition to do things better. You know, to see that the Japanese are much smarter than we are. The so-called what you call pericolo giallo, and you call the yellow peril, and this kind of thing. Maybe there is some components to that. Why people reacted so much to the Takahashi thing and didn't react very much at all. Actually, didn't react at all to the Cold Fusion Conference of Como. But nevertheless, I mean, I'm perfectly happy because essentially this brought the message in, and I hope that we'll be able to do something with it in the near future to change somewhat the situation.
May I ask you, do you know how much the Japanese government is spending on cold fusion today?
I think in the orders of a few tens of millions of dollars a year, something like that.
Our group, Jed Rothwell, who's a fluent Japanese speaker, to get the exact status on that, I think you should talk directly to him, but I've read some of the reports that he's written up briefly. It's hard to make a one-to-one correspondence between Japan and the U.S. because of the way funding is.
Yes.
But in essence, there are something on the order of 200 researchers sort of working on it consistently. You know, it may translate into, depending on how you talk about support equipment and so forth, it may translate into a few tens of millions of dollars. But I think it could well grow much more than that because we have every indication through actual statements by key Japanese officials in hot fusion that they've gone to MITI. You can be Ministry of Industry and Technology and Trade, Ministry of Industry, I always get mixed up, MITI, any of them, yeah. MIT with the I on the end. They've gone there and the seed is planted for funding, and I would be absolutely shocked if within this calendar year they're not in this, and that will be public information, because I don't think MITI keeps secrets like that. The negotiating process to get to their money. Yes?
I'd like to get an idea of what might be some of the future potential technological or energy generating consequences of, let's just take the most optimal time frame for the development of a successful experimental cold fusion device. What are the implications for technology and industry, say, stretched out over the next several decades, say to the next 50 years, concretely? Any guesses?
I'm glad you asked, but you have absolutely the wrong time scale. You're thinking in terms of hot fusion, and this is going to happen very quickly. This is my view. I may be completely wrong on this. In terms of when you can actually get a product into a house, let's say, a home heating system, I think we'll see products within this decade. Okay, I think you'll see home heating systems, maybe even home electric generating systems. I think down the road, since you have to have much higher powers for some of these things, you know, cold fusion powered steam automobiles. Basically the heat will generate steam, will generate electricity, or maybe by some other mode. And I think there will be central station power generation, although I think cold fusion, by its very nature, probably will be a much more distributed type of power system. Much as microcomputers today, you know, take the place of giant mainframes that everyone used to have to plug into. I think that will happen with power sources as we go on. And I think, since I'm an aerospace person, I hope also there will be some very spectacular aerospace applications. In fact, I look toward, the first one will be powering electric ion thrusting engines. I mean, you need a power source for that. And if you could get a fusion power source, wow. I mean, if we can generate a lot of electricity and get, you know, megajoules per mole type sustainable power, I mean, that's incredible what that could do to space travel. And we may even be able to get high temperature. I mean, if you believe some theories of cold fusion, which I don't necessarily partake of, but there are suggestions that we maybe could get cold fusion to high temperatures like thousands of degrees C, which would then open up the possibility of very high performance thermal rockets. It could revolutionize space travel, and it may well. Okay, but the first thing, really, products within the decade, I would hope so. Yeah.
You know, I wish I understood more about your basic subject, but I'm delighted to hear this business of having to overcome serious opposition when it's not valid. I wrote the first college textbook on aeronautics for the Air Force. I know a little bit about airplanes. I'm a jet pilot, and I managed to write the book. The best wing ever designed was designed at MIT and is not flying today because it's too good. The best helicopter ever built was built by Frank Piasecki, and it's not flying today because it's too good. What we need is not only cold fusion. We need to fuse the people who are running into these problems. Now, Dr. Koppen at MIT died with the best airplane plans there were. And I have flown his plane. We bought over 400 of them for the CIA because they operated so well, so secretly. Then the Frank Piasecki plane is not flying at all. But now, these cases are disasters similar to yours, sir. I admit yours is in an area we all would aspire to. But this is going on every day in the scientific world and in the world of engineering. We can't run a railroad in this country. Railroads built North America.
Yes.
We don't know how the hell to tilt the track to make the trains run.
MIT had a magnetically levitated train idea. It was developed at Brookhaven, but Henry Cohn and others developed and patented what I think, at least according to him and what I've explored, the best maglev idea. Tried to interest the government in it. They had a working model which they built on a shoestring budget, tested it out on a 400-foot aluminum track, this videotape of it. Where's maglev? It's dead.
Miyazaki in Japan.
Well, it's dead. That's where it is.
Yeah.
They keep, year after year, as we do in the United States, study contracts. I worked for some of these Beltway bandit types, and we have Beltway bandits up in Boston too, by the way. But their whole modus operandi is studies of studies of studies of studies. And there's yet another study now that's occurring of maglev, as though we need a study to say that this is a good idea. Okay? That it works. It obviously works. It was tested out in 1975. It was patented. Now, of course, the patent rights are gone. And, you know, it's crazy.
So what is your idea why this happens?
I'm sorry?
What is your ideas why this happens,
does this
really?
happen across the board?
Because it interferes with established business that is able to make money with the equipment that isn't as good.
But we are the people. I mean, we are not. We have to try, and this is just the freedom idea. You know, we want that society gets what's best for itself, not for the business people.
Well, the best airplane, the one I told you about, was owned by a consortium of MIT and Harvard people. It was bought up by a major aircraft manufacturer, and now you hear about it at all. None at all. The Piasecki airplane was also bought by the same manufacturer, and now you don't hear it. I don't think I have to tell you anything further.
Yeah, but do we have to put up with this?
We have for 20 or 30 years, without saying as much as you people are about cold fusion. That's why I say this needs to go across the spectrum. Cold fusion is an example of one of the extreme problems.
It is.
Yeah,
There's
but
no more
excuse me,
extreme
if I can interject, however, whereas there you have really some outstanding achievement, technological achievement, what is at stake in cold fusion is really the opening a completely new intellectual scientific field. Is much more, than a great, fantastic technological achievement. Is something that we might eventually put to our. If we understand this behavior in matter, we will be able, I'm sure, to find out smart material, do all kinds of things, because this is, this underscores a behavior of the elementary constituent matters in situations which have never been neither discussed nor dreamed of before. So I think this is just we owe it to our children, we owe it to the future generation that we stick on this and we fight for this, because that will be affecting their lives very much. What I don't understand in all this question of business and so forth, the extraordinary lack of social generosity that this entails. As if, just caring for your fellow citizen, for a fellow human being, was not a part of your being in this world. And this is the thing, that really turned me off for this corporate business, this money and this kind of thing. That people somehow forget the obligation of the more privileged people towards the rest of humanity. This sounds moralistic, but
There's one factor involved here, and it can be summed up in 2 words: journalistic corruption.
There is journalistic corruption to the...
Journalistic corruption,
Well,
sustaining the status quo and running into the ground anybody who comes up with a new idea.
let me tell you that I'm an expert, to some, I think, on science journalism. And there are other experts in the audience, I know some very fine ones here, who have covered cold fusion. I forgot to mention, for example, Chemical Engineering News earlier, and I see Ron Nagani, an MIT graduate, who is here, and he's done good cold fusion articles. But I want to say this in general about how the media has reacted to cold fusion. There's been not nearly what there should have been on this subject. What they did was they reacted to 2 very powerful journals, Nature and Science. When both Nature and Science go after something and call it nonsense, it's pretty hard for even a science journalist with guts to stand up and say, wait a minute, there's still a story here worth covering. People have done that in Chemical Engineering News, in Science News. Science News has had continuing stories. It's not that these journals should say, oh, we believe in cold fusion. No, that's not the point. But when there's a conference, they should talk about the conference. When there are new announcements from Japan, they should talk about that, and so forth and so on. I think there's been an unbelievable moving toward a philosophy of journalism which is absolutely untenable, and that is that the purpose of the journalist is to make sure that what he's reporting on is absolutely true and proved beyond any doubt before reporting it. That's not the way journalism should be. Journalism should be, there is a cold fusion debate going on. There are people in Italy working, there are people in Japan, and there are people attacking them who are saying it's nonsense. Fine. Let people make up their own minds. Don't bury it because you've adopted, and it is the New York Times philosophy, I regret to say. The New York Times has the philosophy, it's been almost explicitly stated by them, that they were reluctant to run the cold fusion story immediately, and they didn't run it immediately, because they wanted to be sure that it was right. Okay, as though they are Nature magazine. They aren't Nature magazine. In fact, some of the reporters, and I won't mention any names, you know who they are, I asked certain basic questions about the physics. I'm not talking complex things, certain basic issues. If you don't know those issues, how do you cover in the story? I got a very unsatisfactory answer. And recently, I called a certain gentleman. I probably shouldn't say things like this. I'm getting into hot water, but I did. I called and I said, I talked this business up a bit, hoping to interest him in it. And I got a yawn over the telephone. Okay, this hasn't appeared in Nature yet. Therefore, it can't be true, in effect. He didn't say that, but...
Nature is the Pravda of the science.
Now, I heard Dr. Chubb back there.
No, even Pravda, finished. Now Pravda doesn't exist anymore.
Dr. Chubb provided me with a gem. He provided me with a tape of the debate between his uncle, who's also a cold fusion true believer, as they call us, and Dr. David Lindley of Nature, who I will say straight out is an incompetent as far as deciding what should go into his magazine and what not. If you listen to that tape, what you hear is Lindley saying things like, oh, it was so confusing, the data were all, it didn't work this way, and there seemed to be inconsistencies, and there never was any theoretical, or this was said recently, there never was any theoretical or experimental foundation for this. Who the hell is he? This is the man who said, chutzpah. Talk about chutzpah. The man said, he said here about theory, this is great. Where are we here? Oh yes, this is in March 29th, 1990, 1 year after. It was nicely planned for that time.
So
It
that
was
the
right for the anniversary.
Yeah.
All cold fusion theories can be demolished one way or the other. How could a man utter such a statement? But it takes some effort. Would a measure of then he said, would a measure of unrestrained mockery, even a little unqualified vituperation, have speeded cold fusion's demise? In other words, if we had mocked this subject on day one, we would have killed it. If you listen to that tape of Lindley debating at the American Philosophical Society, anybody who calls himself a true scientist has got to realize that that man has got some serious problems. And I did before we published Fire from Ice, you know, my publisher was really nervous. Oh, are we giving nature a fair shake? I was even worse. Are we giving them a fair shake? And I said, yeah, we are. We're stating the position just like it is. You know, what more do you want? We gave him Maddox's nature, you know, the bottom line, it's dead and it will remain dead. But I called Lindley up just one more chance, hoping that he might have a deathbed conversion, or wondering whether I was misstating his 1991 position. He couldn't tell the difference between Jones's experiment and Menlove's experiment. I mean, he knew the differences, but I said, why did you not publish Menlove's experiment when, as I understand, 4 out of 5 reviewers said publish it, and a 5th said no? He said, well, they were about the same thing. Well, what he meant, of course, was that they were just neutrons, they were heat. But it's a hell of a thing to have one experiment, Steve Jones, which is Mother Earth's soup, and get some random neutrons that are sort of low level above background, and another that's got pulses. Pulses in an entirely different system. Deuterated titanium. Lindley couldn't tell the difference. I think the man should be fired. But of course he can't be fired because John Maddox is his boss. The best solution would be to get rid of both of them. Okay? But we don't worry about nature because nature's going to die on this. They're going to absolutely die. They're going to have to eat crow. They're going to have the largest plate. And that's it. And if you think this is... How are they going to explain what they did? They had editorials against cold fusion, that statement about mockery, arrogance, incredible. I don't think they will survive, frankly. Quite frankly, I don't really care whether they survive. I just want to label the albatross around them, and it will be around them forever, that they mocked this. And by the way, even if cold fusion were wrong, by some unbelievable circumstance, by which every single experiment done in different areas is all completely wrong, it's still wrong what they did. It's still wrong. Even if cold fusion doesn't exist, which is impossible for me to imagine at least, although it's theoretically possible for everything to be a mistake. It is theoretically possible. Very unlikely.
Chances now are very small.
They're essentially zero, okay? But I'll grant there is some theoretical possibility, remote as that may seem.
Oh, I mean, as big as you tunneling out of this, you know, by quantum mechanics out of this.
Let me make as an expert on journalistic
I know what
corruption.
let me predict
No,
first.
let me make
All
a
right,
prediction.
predict what they're going to do.
Nature, if it comes out 100% for cold fusion, will end up saying, we were right all along and you were wrong.
You're absolutely correct.
And they will survive and you will not.
Right, no, I will survive.
Well,
But the point is,
okay.
because I have documented when I had my opinion, and they don't have documented when they had their opinion. But they are going to say, I predict, and I'm going to write a manifesto somewhere and circulate it to all of them, saying, don't you dare say that Pons and Fleischmann and Eugene Mallove and everyone else in this field made it so difficult for you to understand what was going on by their secretiveness and so forth, that it was hard to see. And if it hadn't been for all their shenanigans, and if they had been more open and so forth, we would have gotten to the bottom of it. Don't say that, Lindley. Don't say it, Maddox, because we're not going to believe it. And that goes for all the others that are killing it, too. We've probably rattled on enough. Are there any other questions? Yes?
Just about the Takahashi work that you were talking about, I didn't catch whether, has it been published or...
Okay, it's been, he wrote up papers, he circulated it all over, notes, they're relatively crude. They're good enough to do an experiment from. He has talked to the scientific American people in Japan and to many other people. He's made a number of presentations at meetings like the ISEM meeting in Japan in this year, January 27th. But he hasn't formally, it's not in a formal peer-reviewed journal. That's true, it isn't. By the way, that whole issue of peer review is completely destroyed now, for probably forever. Because we now know, if we didn't know, we should have known before, that each journal has its own standards of peer review. I mean, publishing in Nature obviously is far different than publishing in Journal of Electroanalytical Chemistry and Journal of Fusion Technology. Each one is a separate standard. And if I follow McCutcheon's, I like McCutcheon's philosophy, which I developed in parallel, which is basically put in almost anything within reason into a journal and have someone comment in parallel on the topic. And let it all hang out. That way, the whole scientific community gets to see both sides of the issue. Why should some journalist, like Lindley, who obviously doesn't know his one anatomical part from another, why should he be in the loop, deciding? Do you realize that there was a whole chain of correspondence, at least a dozen letters, between Noninsky and Lewis at Caltech, and Lindley, Lewis, and Noninsky, over the issue of the errors in Lewis's results. And Lindley said at one point in one of these letters, he said, now I cannot tell the difference between who is right, you or Lewis. And so you would think that as a good editor, one would at that point immediately publish both letters. Publish Noninsky's critique of Lewis's earlier published work in Nature, and publish Lewis's rebuttal. But that has not been done. This is a disgrace and an outrage, and it's just totally anti-scientific. The only thing that can explain that, there's only one thing, and that's arrogance. Arrogance on the part of Lindley, that he's not going to publish something that pulls down even a little bit one of the main pillars of cold fusion attack. By the way, this is apocryphal, but I'm sure it's true, because it fits right in with the pattern of Lewis. Lewis is alleged to be boasting. He boasts to people about the labs that, you can really tell a good lab by how fast they dismissed cold fusion. Can you believe that? You could really tell a good lab by how fast. Well, he's going to be dismissed completely from existence in the scientific world. Yes?
I'd like to offer a different hypothesis. A moment ago, a couple of moments ago, the question was asked, why is this? Why is there constantly an attack on scientific advance, technological advance?
Not always.
Proposed, well, repeatedly there are exemplary cases like the airplane and so on, and right down the decades. So then the answer is, well, it seems that you've got many people who are holding on to what they've got at everyone else's expense.
Yeah.
Well, you hear that now and again. I would suggest a different idea, that it has nothing to do with money as such. Instead, it has to do with social power, namely that the diffusion throughout society of technology like cold fusion means that the world's population has greater access to energy. What this means in the end is that the world's population actually has a sounder basis for becoming literate, for becoming capable. And, well, let me get to the bottom line here. The bottom line is that the capacity of the individual man or woman on Earth to reason about his circumstances is increased by these advances. And therefore, it's not money as such, it's power. It's a tightly held power.
Yeah, I don't myself put it into a grand scheme. You can get into all. I'm used to the idea that human beings are imperfect. I'm not expecting human beings to be imperfect, to be perfect. I don't think of there's a perfect world. I'm not perfect. I'm far from perfect. Okay, but the point is, I think in this discrete case, and in cases like it, there have been other cases where, like for instance, the New York Times mocked, without even knowing what the hell it was talking about, it mocked Robert Goddard. Okay, I mean that was crazy for them to be making an editorial position like that, but they did. You know, I think you have to look at each case, point by point. If there are no other questions, I think we'll just, yeah.
Do you know what Fleischmann's model prototype will look like? I mean, how big and what will it look like?
I haven't the faintest idea, nor do I know, in fact. I haven't heard this announcement myself, and I just do not know. I assume they're eventually going to have a reactor. The sooner the better. Okay, I guess that ends it all. Thank you very much.
I had fully appreciated how you would appreciate that.
Oh, you should tell,
Because
my
you're,
husband's
you're a journalism
Oh,
professor.
you know, I don't want to be a journalism professor. I mean, I'm invited that by almost accident. But the point is,
No, but
I mean, I thought about it.
Just want to say goodbye.
Yeah, shake
Oh,
your
take
hands.
care.
Shake your overhead projector.
Yeah, I know.
If I can get it.
Thank you.
Yeah.
And you take it.
Gentleman called and either of us was standing here talking to you like this.
Right.
And I gave
Oh,
him
that's a congressman. You gave him what?
the sign-in sheet to sign in, but he didn't tell on who he didn't sign it. I never found out really who he was.
Hey, Carl's making me copies of those tapes of my class.
Yeah, he is.
He's an aide to a
Has he done it?
It's, I think there was one before.
Should I turn off the power?
Yeah, you can.
Yeah, I'd like to.
Turn off
Is
the
the
power.
sign?
I have a sign-in sheet here.
Can we Xerox it right now? Can I see it first?
Yes, absolutely.
You got it?
Oh, wait, I started with it.
You did, you wrote to me.
Did I?
The two picture that you were showing, you still have them?
What's this?
The two picture, the color pictures?
This is my letter.
Okay, and you're gonna send me the sign.
Here's the letter of Japanese.
Yes. In fact, yes, I'm sorry. In fact, I thought that was in the package I gave you, but it wasn't.
Thank you.
It's a lot of fun.
Say hello to Brian.
You'd like me to see the experiment.
Oh.
You trust me?
I believe so. When do you expect to have?
Oh, Mike? He passed around.
I never heard of it. You didn't either, right? Yeah, well, I don't even know. Very nice. So I said, well, what kind of experiment?
Whichever,
Exactly tell me. I said, well, maybe I can see it if I get.
Did we get out of control?
I don't think so. Of course, I'm
Who
wild.
do you think the guy was
Who was
left?
who was less in control?
Moderately well restrained, yes.
Read CNN News, you'll find out if you're out of control.
Who was the guy with the sort of British accent that wasn't British? That
Oh, I think he was probably a spy for.
Oh, I couldn't get a copy of this. There's a copy down before.
Let's see. Creators Syndicate?
Yeah.
Salt Lake Desert News was here, Gene.
Oh, yeah, I heard. I saw.
Let me see.
Some little bird told me about that.
Oh, good.
I called them.
What is this?
It's true, right? Okay.
And our.
Well, there
Okay,
would have
let's
been
see.
Africans,
Voice of America
well,
had people.
Ramadan prevented some people from coming who wanted to have all the news. This definitely, yeah, well,
We had a lot
at the end of the month. So,
We'll be over next week.
yeah, so anyway, they want to hear everything.
None of the big wigs at all.
None of the American, except for UPI.
Oh, UPI was
I was here.
Oh, I didn't see that.
But at 1 o'clock
Stayed
on
home
Friday was the
for
worst time, especially for those
initial
who aren't
presentation
working.
by Gene Williams.
Stop and get a cup of
Get
coffee.
a cup of coffee and then.
Because what time?
So hold on 1 second and I'll do that.
3 o'clock.
3 o'clock is plenty of time. We can
There's a
stop.
coffee shop on the second floor, the American Cafe of this
That'd be
building.
fine.
If that's,
I didn't get any lunch.
Now,
I mean, that's what I hear.
I rushed over.
So what do you think? Do you want to go? I think we had success.
Okay.
Well, I think so.
I think it was good to do it.
Probably get sued by Parker, but that's okay.
Oh, come on. They're having a wonderful suit.
Nobody's suing you, are they?
They're suing Preparata and Bressani.
Who's suing
I
Preparata?
can imagine they might.
No, excuse me, I got it the wrong way. They're suing Republica because they slandered him and said they were worse than pedophiles, Martin.
Well, it looks like they're heading down
Why
there
can't
also.
you copy when you get back to the office? What are you gonna do?
Well, he would like to see it, my God.
Oh, well, we can send it to him.